7. So is just answer some questions. So for question 1 is a hash table that hashes all value to the same slot is essentially equivalent to data structure. So it's kind of like essentially equivalent to the linked list data structure. So like multiple value so it's called separate chaining or open hashing. Each of the value in the slot is linked to each other in order of the insertion. The second question is to analyze the hashing functions in our lecture slides and discuss about the benefits and drawbacks of each function. So first one is the most simple one, is loss. So this function, so the benefit of this function is very simple to understand and is very simple to code it or something. And it's very to learn about it, and it's just aid the Unicode characters value of all the alphabets in a word and return that. But it's very easy to cause collision because like when the characters are in different order, but it's still, if it's the same characters, it will result the same value, so will cause collision. So I guess that's the downsides of it. And and because the large size of collision is also very slow. The second one is RS hash. It's very similar to the loss. It's designed to be simple hashing, as we can see here. It's better than loss because it reduces the collision by multiplying two big odd numbers to produce a hash value. It runs at similar speed as loss. It has very nice distribution of hash value as it generates a long hash by multiply two big odd numbers and add the Unicode value to it. And the third one is DJB2 hash. Is the way you calculate it is kind of similar to RS hash, but it have some improvements on top of it. So adding another step of bitwise and to generate a 32-bit long hash, which is to solve the collision problems, to reduce the collision. So it's one of the quickest hashing algorithms and have a very nice distribution of hash values. It uses multiplication of large prime number with an odd number along with bitwise and to produce a 32-bit hash. It is, but it's not very good. As for generating the 32-bit result, it only does bitwise and with the same 32-bit number. So it will still cause collision, like for certain situation. It has very limited best functioning, where hash table needs to be of a specific size with specific key characteristics. The last one is SDBM hashing. It's not very good for crypto, but it works with generating hash for alphanumeric character string or sequence. It also with high degree of variance. It's better than the previous one because it proves the collision situation, and also it's fast compared to the previous one. but for cryptography, it's not that good because networking or hashing. So for the third question is analyze true matter to resolve the collision. So the two matter discussed in the slides are open addressing and as we could see, so it's open addressing and chaining. So open addressing is if the collision opens just if the address already occupied, just increase the index to the next slot available for storage. It could different way like linear probing, quadratic probing, and double hashing. Another way is chaining. If the address is occupied, then just make a linked list and use the index to reference to store in the linked list. If another collision occurs at the same address, just append that value to the linked list. The main advantage is that the hash table will never fill up, as we can always increase the length of the linked list, and it's relatively easy to implement and do not have the problems of load factor and clustering. But it requires extra space as it needs to store links. So unlike like open addressing, it's like more easy logic and there's no need to know the frequency and number of keys. So we could dynamically increase the size of the linked list. The caching performance of chaining is not very good. If the hash function generator is the same value, the large number collision and the same index, then the length keeps on increasing and reduce the performance for search. Then the fourth question is how to solve when you need to resize a hash table and how to address them. So when there are two situations, is like all related on load factor. Is when it get too large or when it get too low. So when it get too large, we need to increase the size of the hash table to maintain the average complexity. But it drops too low without waste of memory, so we need to reduce the size of the hash table. So when we create a new table, we need to consider the hash function to map to the new size. By adding elements from the previous table and to calculate the new tables and to resize it, like decrease or increase. And if we're using open address or chaining in the previous hash table, we need to decide if we still want to use this method in the next table. So that frequent resizing and complexity due to open address and chaining are avoided. Usually when resizing hash table, we consider the last operation. Also, the new hashing function should eventually dispute the previous elements to avoid further clustering and resize complication in newly generated hash table. Efficient way to perform hashing to use a universal hashing where a hash function is randomly selected from a group of hash functions.